Two syntheses of mescaline for you today. The first one was done by these people, whose names I won't try and pronounce. They disconnected at these positions and started with 2,6-dimethylphenol. The first reaction was a Mannich reaction using dimethylamine and formaldehyde. The first thing that happens is the nitrogen condenses, pushes off a molecule of water, and gives us this reactive Mannich intermediate. The phenolic OH pushes electrons through the ring and adds on to the carbon. That gives us our product here, which deprotonates to restore aromaticity. And our final product is here, after 10 days of reaction. Methyl iodide was used to alkylate the nitrogen and turn it into a quaternary amine salt. That quaternary amino group is apt to be displaced by a cyanide ion provided by potassium cyanide, and gives us a terminal nitrile with the generation of trimethylamine as the byproduct. The terminal nitrile is reduced with lithal. This reaction is fairly straightforward. You have your cyanide group, which is reduced twice. A hydride ion attacks the carbon, pushes the charge up onto the nitrogen and generates some aluminium adduct, which happens twice to give this species. A workup with water hydrolyzes those weird bonds and gives us a more traditional terminal amine, which is the terminal amino group of mescaline. Of course, Shulgin did this as well. He started with this starting material, and he used cyclohexylamine and nitromethane in a condensation reaction. The nitromethane has a highly acidic proton which falls off and generates a nucleophilic intermediate like this. One of those oxygens pushes electrons back and enables it to condense with the aldehyde group, and we get a styrene like we saw in the last video, and you will reduce it with lithal as usual, and that gives us mescaline.